The True Story of 3I/Atlas, a 2-hour guided sleep story, real science, slow narration, no ads, stellar secrets, sleep, close your eyes, take a slow breath in through your nose, hold it for just a moment, and let it go again. In slowly, out slowly. You are safe. You are warm. The surface beneath you is holding you completely. You don't need to hold yourself up tonight. You don't need to be anywhere or do anything or remember anything. Tonight, we are going somewhere extraordinary, somewhere that no human has ever stood, somewhere that existed long before our sun was born, long before the first star lit the darkness of an infant universe, long before the word darkness existed to describe anything at all. Tonight, we are going to follow a visitor, a traveler from beyond the edges of our solar system, an object older than memory, older than the oceans, older than the mountains, an object that has been moving through the cold, perfect silence of interstellar space for longer than the Earth has existed. It has no name in any human language. It has no home that we can point to on any map. It belongs to no star and no world. It is simply moving, as it has always moved, through the dark. But in the summer of 2025, our telescopes found it. And for the first time in recorded human history, we watched something from another star system enter our solar neighborhood, silently, slowly, in geological time, like a ghost passing through a lit window on a winter night. We called it 3I/Atlas, and this is its story. There is nothing you need to do right now, nowhere you need to be. Your body is heavy and warm, sinking gently into whatever surface holds you. Your breathing is slow. Your thoughts are beginning to soften at the edges, the way thoughts do when sleep is near. For the next 2 hours, you are simply going to listen. Let the words wash over you like a slow tide, like the sound of rain on a window. You don't need to hold on to any of it. You don't need to remember. You don't need to understand every detail. Just let the story carry you. We begin at the very beginning, before the object, before the telescope, before the moment anyone knew to look. We begin in the dark. Imagine the space between stars, not space as we usually picture it. That bright, busy panorama of planets and moons, and asteroid belts and nebulae that fills the pages of astronomy books, not the space of science fiction, lit up with starships and colorful gas clouds and the drama of galactic civilizations. I mean the real interstellar void, the actual gap between one star and the next. It is almost nothing. The nearest star to our own sun is Proxima Centauri, a small red dwarf star 4.24 light years away. A light year is the distance light travels in a single year, moving at 300,000 kilometers every second. To put that in terms our minds can almost grasp, if you shrank our entire solar system down to the size of a dinner plate, Proxima Centauri would be roughly 1.3 kilometers away. Across a city, around the corner, and down several streets. The space between them is not empty, but it is very, very close to it. It contains a few stray hydrogen atoms per cubic centimeter, wisps of interstellar dust, thinner than the thinnest fog ever produced on Earth. Magnetic fields stretched across incomprehensible distances. Cosmic rays, high energy particles flung out by ancient supernovae, streaming through at nearly the speed of light, and objects, wandering objects, small bodies of rock and ice, or perhaps metal and something stranger, drifting through the darkness at dozens of kilometers per second, pulled by no single gravity, owned by no single star, carried by the slow, patient momentum of their ejection from some long ago planetary system. These are the interstellar interlopers. We had long suspected they existed. Theorists had written equations about them for decades. Computer models had predicted that every planetary system in our galaxy, every one of the hundreds of billions of star systems in the Milky Way, produces excess material during its formation. Material that gets flung outward by gravitational interactions with forming planets. Material that achieves escape velocity and continues forever into the void. Our own solar system does it too. The Oort cloud, that vast, cold, roughly spherical shell of cometary nuclei at the very edge of the sun's gravitational reach, extending perhaps a quarter of the way to the nearest star, is full of objects that have barely moved since the solar system formed 4.5 billion years ago, and occasionally one of those objects is dislodged by the gravitational influence of a passing star. by the gentle but persistent pull of galactic tides, by chance interactions within the cloud itself. Some of those dislodged objects fall inward toward the sun, and we see them as long-period comets, visitors from the deep cold, making their first and only close pass around our star. Others are flung outward, lost to the solar system, sent on trajectories that carry them into interstellar space to travel indefinitely, at velocities that mean they will never encounter another star for millions of years, and other stars, all other stars with planetary systems, do exactly the same thing. The Milky Way is full of these wanderers, trillions of them, according to theoretical estimates, perhaps hundreds of trillions, moving through the interstellar medium in every direction at velocities set by the circumstances of their ejection, carrying the frozen chemistry of their birth environments in their interiors, untouched by any star's warmth for eons. Before 2017, all of this was theory, beautiful, well-reasoned theory, but theory nonetheless. We had never actually seen one. Then, on the 19th of October, 2017, everything changed. Let your shoulders relax as you breathe. Feel the weight of your arms resting, the warmth of the air around you. There is nothing to do right now, nothing to fix or plan or remember. Just breathe and listen. The discovery was almost accidental. Robert Warwick, an astronomer at the University of Hawaii, working with the Pan-STARRS, one telescope on the summit of Haleakala, was reviewing images from a routine sky survey when he noticed something unusual. An object moving across the sky at a speed and on a trajectory that didn't match any known solar system body. The calculations were run and rerun and run again by independent teams. The object had arrived from outside our solar system. It was given the name Oumuamua, a Hawaiian word meaning roughly a messenger from afar arriving first. And it was extraordinary in every possible sense. It was moving too fast. Its trajectory was hyperbolic, meaning it was not bound by the sun's gravity, had arrived from interstellar space, and would leave, never to return. But beyond that, it was accelerating As it moved away from the sun, it was speeding up in a way that could not be explained by solar gravity alone, or by the gentle pressure of sunlight, or by any mechanism that astronomers could definitively account for. It showed no visible coma, no tail, no evidence of outgassing, and yet it was accelerating. The debates began and have never entirely stopped. Some researchers proposed that Oumuamua was a fragment of a nitrogen ice body, a piece of a Pluto-like world from another system, flattened by billions of years of surface erosion into a thin, pancake-like shape. The acceleration on this model was caused by a tiny amount of sublimating nitrogen ice, too faint to detect spectroscopically. Others, most famously the Harvard astrophysicist Avi Loeb, noted that the object's behavior was consistent with a light sail, an extremely thin, manufactured structure pushed by the pressure of sunlight, not driven by an engine, not guided by intelligence during its passage through our system. Simply a piece of technology, or something resembling technology, drifting through space. The mainstream scientific community received this suggestion coolly. Extraordinary claims require extraordinary evidence, and the evidence was ambiguous. What was not ambiguous? Oumuamua was the first confirmed interstellar object in recorded history. It tumbled as it moved, brightening and dimming in a regular pattern, unlike any known natural body. It was perhaps 400 meters long, possibly disc-shaped, and it came from a direction roughly consistent with the motion of the local standard of rest, meaning it had been essentially stationary relative to the average motion of nearby stars, waiting in the interstellar medium for the solar system to come to it, and then it was gone. We watched it for only 80 days before it moved beyond the reach of our best telescopes. By the time we understood what we were looking at, it was already leaving. We had no time to send a mission, no time to collect a sample, no time to get close enough to answer any of the questions it raised. We simply watched it go. The scientific community was left with questions that may never be fully answered. and a new awareness. Interstellar objects are real. They pass through our solar system, and we were not prepared. 3 years later, a second interstellar visitor arrived. This one, named Borisov, after the amateur astronomer who discovered it, was immediately recognizable as a comet, complete with a coma and a tail. It was more ordinary in some ways. Its chemistry broadly similar to solar system comets, which told scientists something profound. The molecular building blocks of planetary systems are universal. Borisov passed through, left, and the telescopes kept watching, waiting for the next one. In 2025, the wait ended. The asteroid terrestrial impact last alert system, ATLAS, is a network of telescopes built for a specific and urgent purpose: to find objects on collision courses with Earth, and to find them in time to do something about it. The network spans 4 sites: 2 in Hawaii, 1 in Chile, 1 in South Africa, and a station in the Canary Islands. Together, they scan the entire sky accessible from those locations every night, automatically, relentlessly, using wide-field cameras capable of detecting objects far too faint for the naked eye. The system generates an enormous amount of data. Every night, hundreds of thousands of new detections. Most are known objects, cataloged asteroids, variable stars, distant galaxies, flickering with the activity of their central black holes. The automated pipeline filters and sorts and classifies, flagging the unusual for human review. A night in the summer of 2025, the pipeline flagged something, a point of light moving against the background stars with a speed and direction that didn't match any known solar system object. Not an asteroid, not a known comet, something new. The trajectory was calculated. The object was coming from outside the solar system. The notification went out to the wider astronomical community within hours. Within days, telescopes around the world and in space were training their instruments on this new point of light. was given the designation 3I/Atlas, the third interstellar object ever detected, found by Atlas, and it was bigger than anything that had come before. Early estimates of the object's size, based on its brightness and assumed reflectivity, suggested it was at least a kilometer across. Some models placed it at several kilometers, large enough to have significant internal structure, large enough to survive the stresses of its long journey through interstellar space, large enough to outgas dramatically as it warmed in the increasing sunlight of the inner solar system. And outgas it did. Unlike Oumuamua, which showed no detectable activity, 3I/Atlas began developing a coma almost immediately after discovery. A fuzzy halo of ejected material surrounded it and grew as it approached the sun. Faint jets, detectable in the highest resolution images, erupted from the sunward side of the object, carrying material that had been frozen since before our solar system existed. The object was breathing, coming alive after its long, cold journey. The spectral analysis began. Water ice, present as expected. The chemistry of water is universal. It forms wherever hydrogen and oxygen meet in sufficiently cold conditions, which is to say, almost everywhere in the universe, beyond a certain distance from a star. Carbon dioxide, present, with an interesting ratio to the water. And then the anomalies. Spectral features that didn't match reference spectra for any known solar system material. Features that sparked immediate, vigorous debate in the astronomical community and have not yet been definitively explained. Something about 3I/Atlas was different. Something about its chemistry was new. Your breathing is slow and even. In, out, in, out. The mattress beneath you is perfectly soft, perfectly supportive. You are exactly where you are supposed to be. Let the weight of the day dissolve into the surface beneath you. Let your thoughts become quieter and continue listening. Let us follow this object backwards, through time, through the dark, we do not know with certainty where 3I/Atlas originated. Its trajectory, traced backward through orbital mechanics, points in a general direction, roughly from the direction of the constellation Lyra, near the bright star Vega. But Vega is not necessarily its parent star. Stars move. Over millions of years, the relative positions of stars in the galaxy shift significantly. The direction the object came from today tells us where it was coming from recently, not where it started. What we can estimate is how long it has been traveling. Its velocity relative to the average motion of nearby stars, roughly 30 kilometers per second. Combined with what we know about stellar neighborhoods and typical ejection velocities, suggests the object has been in interstellar space for somewhere between several 100 million and a few billion years. Breathe in. Hold that number gently in your mind. A billion years. A billion years ago, the most complex life on Earth was still single cell. The oceans were full of bacteria and simple algae. The first multicellular organisms had barely begun to experiment with their new architectural possibilities. The continents were arranged completely differently, recognizable to a geologist, but alien to any traveler from today. While all of that was happening, while all of the Cambrian explosion and the emergence of fish and the colonization of the land and the rise and fall of the dinosaurs and the evolution of mammals and the emergence of primates and the development of human intelligence and language and writing and science. While all of that was unfolding over 400 million years, 3I/Atlas was out there, drifting in the cold, in perfect silence. It did not know any of this was happening. It cannot know. It is a rock, or a ball of ice and rock and dust and ancient chemistry, incapable of knowledge or experience. But it was there. It was real. While the first fish crawled onto land, the object was drifting somewhere in the Orion arm of the Milky Way. While the dinosaurs evolved, it was in the darkness between two unnamed stars, while humans built the pyramids and learned to sail and invented the printing press and launched satellites. While all of that happened, it was moving silently through the void on a trajectory that would eventually bring it here. The first photon from our sun to touch this object probably arrived only a few thousand years ago, when the object was still in the outer reaches of the solar system. A single photon, undetectable but real, the beginning of a warming that would, over the following centuries and millennia, slowly, imperceptibly change the object's surface, and then it began to wake. The ice at the surface, frozen since the object's formation around a star we will probably never identify, began to sublimate. Molecule by molecule, the outermost layers began to convert directly from solid to gas, expanding outward into the vacuum in thin jets, carrying with them the dust and complex organic material that had been locked in that ice for longer than our world has existed. It was exhaling. It was releasing into our solar system a tiny fraction of the chemistry of another star's world. And we were there, with our telescopes and our spectroscope and our orbital mechanics and our late nights and our profound, insatiable curiosity to watch it happen. There is no other word for it but extraordinary. Settle deeper into the warmth around you. Feel your body heavy. Feel the day receding. You are safe here, in this moment, on this planet, and the universe is vast and ancient and full of wonders that require nothing from you except occasionally your attention. A comet is a time capsule. Everything it contains was present when it formed. The ices, the dust, the complex organic molecules, the silicate minerals, all of it is a frozen record of conditions in the protoplanetary disk where the object was assembled. That disk formed from the same cloud of gas and dust that made its parent star, shaped by the specific composition of that cloud, which was in turn shaped by the history of the galaxy in that particular location at that particular moment in time. Our own comets are time capsules from the formation of our solar system 4.6 billion years ago, When scientists studied Comet 67P with the Rosetta mission, landing on its surface, sniffing its vapors, analyzing its composition in extraordinary detail, they found a remarkable mixture: water ice, carbon monoxide, carbon dioxide, methane, ammonia, hydrogen sulfide, complex organic molecules, including glycine, the simplest amino acid, phosphorus, one of the essential elements for life as we know it. The precursors of biology, frozen in a comet formed before the Earth existed. These molecules did not come from living things. They formed through purely chemical processes in the cold, UV-irradiated molecular clouds where stars are born. But they are the same molecules that, given the right conditions, liquid water, a stable energy source, the right temperatures and pressures, and the right amount of time, can organize themselves into the first flickering, fragile structures of biology. When scientists turned their spectrometers on 3I/Atlas, they were hoping to read a different time capsule, a capsule from somewhere else, from some other star's formation, from a disk that spun and accreted and produced planets, or failed to fully produce planets, under conditions different from our own. The water ice signal was strong and clear, reassuring in its way. Water is everywhere in the cold universe. The physics and chemistry of hydrogen and oxygen are the same everywhere. The carbon dioxide signature was present, with an intriguing ratio to the water, slightly different from what we typically see in solar system comets. Not dramatically different, but measurably, reproducibly different. And then the anomalies. In the near-infrared spectrum, there were features, absorption lines at specific wavelengths that didn't match any known reference spectrum. Not any solar system comet, not any known asteroid, not any known dust mixture, not any known molecular ice combination. The community offered explanations. The most conservative, the interstellar medium, had done its work. For hundreds of millions of years, cosmic rays had been bombarding the surface of 3I/Atlas, breaking molecular bonds and rearranging atoms into configurations that don't form under normal conditions. The unusual spectral features were irradiation products, artifacts of the journey, rather than markers of the origin. A second possibility. The parent star had a different metallicity. Stars form with different proportions of heavy elements, depending on where and when in the galaxy's history they were born. Older stars from the galaxy's early history tend to have lower metallicity, fewer heavy elements, because those elements hadn't yet been produced by the first generation of stars. Younger stars, formed from molecular clouds already enriched by billions of years of stellar nucleosynthesis, tend to have more. The metallicity of the parent star affects the chemistry of its protoplanetary disk, changing the ratios of molecules that can form, the mineralogy of the dust, the composition of the ices. If 3I/Atlas came from a star with substantially different metallicity than our Sun, its chemistry would be genuinely different. Not by magic, not by mystery, simply by the ordinary chemistry of a different raw material. And a third possibility, voiced carefully with all appropriate scientific hedging in a small number of preprints and conference presentations, was more provocative. What if some of those anomalous organics were truly complex, not just simple precursors, but longer chains, more intricate structures, molecules that we associate more with biology than with simple astrochemistry? What if the parent system had, at some point, harbored conditions where chemistry had proceeded further along the path from simple molecules to complex ones? Nobody was claiming life. The data did not support that claim and would not have, even if the measurements had been perfect. Life requires more than complex molecules. It requires organization, self-replication, metabolism, the emergence of systems that can maintain themselves against the universal tendency toward disorder. But the questions were being asked, and questions in science are the beginning of everything. Slow your breathing a little more now. In for 4 counts, out for 6. Let each exhale carry something away with it. A worry, a thought, a tension you didn't know you were holding. There is nothing required of you right now except to breathe and to be here. There is something deeply, fundamentally human about the desire to see further than our eyes allow. Our eyes are remarkable instruments, evolved over hundreds of millions of years to detect the particular wavelengths of light produced by a G-type star filtered through a nitrogen-oxygen atmosphere, reflected off the surfaces of objects we needed to find and avoid and hunt. They are exquisitely tuned to the visible spectrum. They can detect a single photon under the right conditions. They can distinguish millions of colors, but they cannot see a kilometer-wide object in the outer solar system. Not even close. For that, we needed to build something larger. The history of telescope development is a history of ambition. Galileo's instrument, which he turned on Jupiter in 1610 and found 4 moons circling it, proving that not everything in the sky orbited the Earth, magnified perhaps 30 times. It was a tube of glass a few centimeters across, revolutionary beyond measure for its time. Today, we have the James Webb Space Telescope. Webb was launched on Christmas Day 2021, folded into a shape small enough to fit inside an Ariane 5 rocket, and unfurled over the following weeks at a gravitational equilibrium point called L2, 1.5 million kilometers from Earth in the direction away from the Sun. There, shielded from solar radiation by a sun shield the size of a tennis court, it cooled to operating temperature minus 233 degrees Celsius, colder than some regions of interstellar space. It had to be cold. Webb is an infrared telescope designed to detect heat radiation from the faintest and most distant objects in the universe. Any warmth in the telescope itself would overwhelm the signal from what it was trying to see. Webb's primary mirror is 6.5 meters across, composed of 18 hexagonal segments of beryllium coated with gold. It collects roughly 7 times as much light as the Hubble Space Telescope. Its sensitivity to the spectral signatures of molecules, its ability to read the chemical fingerprints in the light of distant objects, is extraordinary. When astronomers pointed Webb at 3I/Atlas, they were able to detect molecular signatures with a precision that would have been unimaginable even a decade earlier. Meanwhile, on the ground, a different kind of eye was opening. The Vera C. Rubin Observatory, perched on Cerro Pachon in the Chilean Andes, at an altitude of 2,715 meters, houses the largest digital camera ever built for astronomy. 3.2 billion pixels, covering a field of view roughly 40 times the area of the full moon on the sky. It is designed to survey the entire southern sky every 3 nights, building up a 10-year record of how the sky changes. Rubin was in its early science phase when 3I/Atlas was discovered, but its contribution was invaluable. Night after night, as the object moved through the inner solar system, Rubin tracked it, adding observations to the growing collective portrait. And alongside these technological giants, there were hundreds of smaller contributors. Professional astronomers at universities and research institutes around the world. Amateur astronomers with expensive backyard setups, contributing photometry, precise brightness measurements that added to the statistical picture. Graduate students running data reduction pipelines at 3 in the morning, sustained by coffee and the profound privilege of being part of something extraordinary. Science is, at its core, a collective enterprise. No single person, no single telescope, no single institution sees the whole picture. The portrait of 3I/Atlas was assembled piece by piece, observation by observation, calculation by calculation, by hundreds of people who would never meet, working in darkness on opposite sides of a spinning planet, all looking at the same strange light in the sky. There is something worth holding in that image. 1,000 people in the dark, looking up, together, each one adding a tiny piece to a picture that none of them could see alone. That is what it means to do science. That is what it means to be human. Let the silence settle around you now. Real silence. Not the silence of a quiet room where your own heartbeat and the faint sounds of a building and the world outside still reach you. Real silence. The silence of the interstellar void. Space is not quiet in the way we sometimes imagine it. It is filled with electromagnetic radiation, light in all its forms, from the longest radio waves to the most energetic gamma rays. It hums at every wavelength with the light of stars and galaxies, with the afterglow of the Big Bang, filling every corner of the observable universe at a uniform temperature of 2.7 degrees above absolute zero, gravitational waves pass through it constantly. Ripples in the fabric of space-time, produced by colliding black holes and merging neutron stars, stretching and compressing space itself as they travel at the speed of light through everything and everyone, detected only by instruments of extraordinary sensitivity. But sound, vibration transmitted through a medium, is absent. There is no air in interstellar space, no water, no material dense enough to carry a pressure wave across any meaningful distance. The shock waves of supernovae expand within the dense material of the dying star, but they dissipate quickly into the surrounding void. The explosions that reshape galaxies are, from a distance, perfectly silent. If you were somehow suspended in interstellar space, warm, safe, no danger whatsoever, and you listen, you would hear nothing, not the thoughtful nothing of a meditation, but the absolute, complete, physical nothing of the absence of vibration. 3I/Atlas has moved through the silence for hundreds of millions of years. It does not experience the silence, of course. It is a body of rock and ice and ancient chemistry, incapable of experience. But there is something meditative about the image. This ancient object, older than complex life on Earth, moving through perfect silence at 30 kilometers per second, alone in the void between stars. The Japanese concept of ma, the meaningful pause, the significant emptiness, the silence that is not absent but present, applies here. The space between stars is not nothing. It is potential. It is the medium through which these ancient travelers move, carrying the chemical memory of their origins across unimaginable distances and unimaginable time. 3I/Atlas spent hundreds of millions of years in that potential, and then, almost imperceptibly at first, a change began. The faintest gravitational influence of a distant yellow star began to curve its path, slightly, infinitesimally, but enough. It was coming here. Your body is heavy and still. Your breathing is slow. There is a warmth around you that is the warmth of your bed, your room, your world. Outside, the stars are there, whether the clouds hide them or not. The universe is there, vast and ancient and indifferent to schedules and worry lists, and everything that keeps us awake when we should be sleeping. Let it all be very, very far away. Here rhythm of your breathing.